Good day everyone, I'm Anjo Inday and I'm here to discuss about the different types of sailing. The first one we're about to discuss is parallel sailing. It simply means sailing along a parallel of latitude, which means that the point of departure and the point of arrival have the same latitude. And since we're not changing latitude, our course will only be east 090 degrees true or west 270 degrees true. This also means that the distance traveled will be equal to the departure. One formula will be used in this. It is cosine latitude is equal to the departure over d law. Example: a vessel departed heading west from 50 degrees south, 26 degrees east for 100 nautical miles. Find its arrival position. Since the problem stated that the vessel is heading west, the course is simply 270 degrees true. And in order to find the arrival position, we must find first the difference of longitude. Using the using the formula cosine latitude is equal to the departure over d law, we can make this into d law is equal to the departure over cosine latitude. Substitute the variables. We have 100 over cosine 50 degrees. It resulted into 155.57 minutes west, and convert it into degrees. We have 2 degrees 35.57 minutes west. The next step is to subtract The next step is to sub the next step is to subtract the d law from longitude 1. We have 0.026 degrees east minus 2 degrees 35.57 minutes west. The answer will be 0.23 degrees 24.43 minutes east. So therefore, our arrival position will be 50 degrees south, 23 degrees 24.43 minutes east, and the course will be 270 degrees through. The next we're about to tackle is plain sailing. It is sailing along a track where point A and point B are not on the same latitude. It is restricted only to 600 nautical miles since there will be miscalculations beyond this distance. We have the plain sailing triangle, which shows that the difference of latitude is the vertical side of the triangle, the departure is the horizontal side, and by joining the A and B, we get distance, and the angle between the dilat and the distance is the course. From this triangle, we can derive the trigonometric functions that are used in the problems involving plain sailing. We have sine course is equal to the departure over distance, cosine course is equal to the difference of latitude over distance, and tangent course is equal to the departure over distance. Another formula used is cosine mlat is equal to the departure over d law. Mlat means mean latitude. If both points are in the same hemisphere, we will add both latitude and divide it by 2, and subtract it if it's not in the same latitude. MV Rubina departed from 15 degrees 25.67 minutes south, 25 degrees 35 minutes west, on course 100 degrees through, for a distance of 350 nautical miles. Determine the vessel's arrival position. First, we can convert 100 degrees through into south 80 degrees east. Then we must find dlat. We can obtain this by using the formula cosine course is equal to dlat over distance, and changing it into dlat is equal to cosine course times distance. Substituting the variables, we have cosine 80 times 350, which answers into 60.78 minutes south. We can convert it into degrees, and we have 1 degrees 0.78 minutes south. The next step is to find the latitude variable. We can find this by adding the dlat to the initial position. We have 15 degrees 25.67 minutes south plus 01 degrees 00.78 minutes south. We have 16 degrees 26.45 minutes south. Then the next step is to finding mlat. Since both latitudes are in the same hemisphere, we must add. We have 16 degrees 26.45 minutes plus 15 degrees 25.67 minutes. over 2, we have 15 degrees 56.06 minutes south. Then the next step is to find the departure. Using the formula sine course is equal to the departure over distance, we can change it into departure is equal to distance times sine course. We have 350 times sine 80, which is equal to 344.68 minutes east. Then we must find the departure of longitude by using cos m lat is equal to the departure over d law. Changing it into d law is equal to the departure over cos m lat. Substituting the variables, we have 344.68 divided by cosine 15 degrees 56.06 minutes is equal to 358.45 minutes east, or is equal to 5 degrees 59.43 minutes east. Then we can subtract d law from the longitude of departure to obtain the longitude of arrival. We have 25 degrees 35 minutes west minus 5 degrees 59.43 minutes east. The answer will be 19 degrees 35.57 west. Therefore, the arrival position is 16 degrees 26.45 minutes south, 19 degrees 35.57 minutes west. The next thing we are about to tackle is middle latitude sailing, or commonly known as mid-lat sailing. It is a combination of plain sailing and parallel sailing. The formula used in this one is sine course is equal to the departure over distance, cosine course is equal to the d-lat over distance, tangent course is equal to the departure over d-lat, and departure is equal to d-law times cos m-lat. For example, a vessel departed from 15 degrees 20 minutes north, 90 degrees 20 minutes east, and arrived at 13 degrees 10 minutes north, 85 degrees 50 minutes east. Determine the course and distance. First, we must find the d-lat. We can obtain this by subtracting both the latitudes since they are both in the same hemisphere. We have 15 degrees 20 minutes north, 13 degrees 10 minutes north, which is the answer is 2 degrees 10 minutes south, or converting it into minutes by multiplying the degree by 60 and adding the minutes, we have 130 minutes south. The next is to obtain the d-law. Since both the longitude are in the same hemisphere, we must subtract it. We have 90 degrees 20 minutes east minus 85 degrees 50 minutes east is equal to 4 degrees 30 minutes west, or equal to 270 minutes west. The next step is to find the mean latitude. Since both the latitude are in the same hemisphere, we must add. Therefore, 15 degrees 20 minutes plus 13 degrees 10 minutes divided by 2 is equal to 14 degrees 15 minutes north. The departure can be found by using the formula departure is equal to d-law times cos m-lat. 270 times cosine 14 degrees 15 minutes is equal to 261.69 minutes west. The next is the course. By using tan course is equal to the departure over d-lat. Substituting the variables, we have 261.69 over 130, which answers to 2.013. In a scientific calculator, we can use the shift tan function, and which equals to 63.58, or 243.58 degrees true. The next thing we are about to find is the distance. We can use the formula cosine course is equal to d-lat over distance, which can be changed into the distance is equal to d-lat over cosine course. Substituting the variables, we have 130 divided by cosine 63.68, which is equal to 292.17 nautical miles. Next, we have the Mercator sailing. Mercator sailing is similar to the plain sailing, except that plain sailing is used for smaller distances. Similar to plain sailing, we also have Mercator sailing triangle, and we can observe in the illustration that the smaller triangle is the plain sailing triangle. In the larger triangle, the vertical side is the DMP, and the horizontal side is a dilo, and the side connecting point A from point B is the same in plane sailing, which is the distance, and the course is also the same from plane sailing. From this triangle, we can derive these formulas. Tangent course is equal to dlo over dmp. Cosine course is equal to d lat over distance. Sine course is equal to departure over distance. To get the meridional parts of the latitudes, we must use a scientific calculator. The formula is latitude divided by 2 plus 45 tangent log times 7,915.7 minus sine latitude times 23.3. Now, if the latitude are in the same hemisphere, we must subtract, and if it's not, we must add so that we can get the DMP. For example, a vessel de- a vessel departed from 10 degrees 10 minutes north, 50 degrees west, on course of 250 degrees through, for a distance of 3,036 nautical miles. Find the arrival position. Now 250 degrees through can be converted into south 70 degrees west. Find the DLAT. Using the formula cosine course is equal to DLAT over distance, you can change it into DLAT is equal to cosine course times distance. Substituting the variables, we have cosine 70 times 3,936, which is equal to 1,346.19 minutes south. Convert it into degrees by dividing it into 60. We have 22 degrees 26.19 minutes south. Then we can obtain the latitude of arrival by subtracting it from the latitude of departure. We have 22 degrees 26.19 minutes south minus 10 degrees 10 minutes north. We have 12 degrees 16.19 minutes south. To get to the MP, we must use a scientific calculator and input both the latitude into the formula as stated before. If done correctly, we have latitude 1 is equal to 609.113 north, and the meridional part of latitude 2 will be equal to 736.930 minutes south. We can, since both latitudes are in different hemisphere, we must add, and this will be equal to 1346.04 dmp. The next step is to find the DLO. We can obtain this by using the formula tan course is equal to DLO over dmp. Changing it into DLO is equal to tan course times dnp. Substituting the variables, we have tan 70 times 1346.04, which is equal to 3628.21. And converting it into minutes by dividing it by 60, we have 61 degrees 38.21 minutes west. Now, we can obtain the longitude of arrival by adding the DLO into the longitude of departure. We have 61 degrees 38.21 minutes west plus 50 degrees west, which answers into 111 degrees 38.21 minutes west. Therefore, the longi- therefore the arrival position will be 12 degrees 16.19 minutes south and 111 degrees 38.21 minutes west. The last that we are about to tackle is the Great Circle sailing. The Great Circle sailing means sailing between 2 points according to the arc of a great circle. It is the closest approximation we have to steering along the exact curvature of the Earth. It is used for long ocean passages, normally passages between east to west or vice versa. For example, a vessel departed from 40 degrees 40 minutes north, 170 degrees west, and arrived at 20 degrees 30 minutes north, 90 degrees east. The first step is to find the difference of longitude. We can obtain this by adding both the longitudes since they are from different hemispheres of the Earth. We have 170 degrees west plus 90 degrees east, which is equal to 260 degrees east. But since it is more than 180 degrees, we have to subtract it from 360 degrees. The final answer will be 100 degrees west. The next step is to find the great circle distance. We can find this by using the formula cosine latitude 1 times cosine latitude 2 times cosine dilo plus minus sine latitude 1 times sine latitude 2. We have to add if both the latitude are in the same hemisphere and subtract if not. Therefore, in this problem, we have cosine 40 degrees 40 minutes times cosine 20 degrees 30 minutes times cosine 100 degrees plus sine 40 degrees 40 minutes times sine 20 degrees 30 minutes. Now, the answer will be negative 0.12337331 plus 0.22821517, which is equal to 01 which is equal to 0.10484181. And in the scientific calculator, we can use the function shift cos, which can be equal to 83.98 or equal to 83 degrees 58.92 minutes, which is also equal to 5038.92 miles. The next step is to find the initial course. We can find this by using the formula sine latitude 2 plus minus the product of cosine distance times sine latitude 1 all over cosine latitude 1 times sine distance. Now we have to subtract if the latitudes are in the same hemisphere and add if not. Therefore, in this problem, we have sine 20 degrees 30 minutes minus the product of cosine 83 degrees 53.32 minutes times sine 40 degrees 40 minutes all over cosine 40 degrees 40 minutes times sine 83 degrees 53.92 minutes. Now the answer will be 0.368290.218. And by using the shift cost function of the calculator, we can obtain 68.38, which is equal to 291.62 degrees true. The next step is to find the final course. The formula for this is cosine Fc is equal to sine latitude 1 minus the product of cosine distance times sine latitude 2 all over sine distance times cosine latitude 2. For this problem, we have sine 40 degrees 40 minutes minus the product of cosine 83.88 degrees times sine 20 degrees 30 minutes all over sine 83.98 degrees times cosine 20 degrees 30 minutes. The answer of this will be 0.660144441, which is equal to 48.69. And converting it into true course, we have 228.69 degrees true. The next step is to find the latitude and longitude of vertex. In latitude of vertex, the formula will be cosine latitude 1 times sine initial course. In this problem, we have cosine 40 degrees 40 minutes times sine 68.38. The answer will be 0.705150582. And by using the shift cost function, we can obtain 45.15 north. The name for this is according to the name of the latitude 1. Since latitude 1 is north, we name this north. So this will be equal to 45 degrees 09.5 minutes north. Now to obtain the longitude of vertex, we must first find the dilo of vertex. The formula for this is sine dilo v is equal to cosine initial course times sine lat v. In this problem, we have 68.38 minus. In this problem, we have cosine 68.38 minus sine 45.15, which is equal to 0.519706884. And using the shift sign function, we can obtain 31.31 or 31 degrees 18.76 minutes west. To obtain the longitude of vertex, we must add it to the longitude of departure. We have 31 degrees 18.76 minutes west plus 170 degrees west. The answer will be 201 degrees 18.76 minutes west. Since it is past 180 degrees, we must subtract it from 360 degrees. The final answer will be 158 degrees 41.24 minutes east. Next is to find the waypoints to create a successive latitude points along a great circle track. First, we must find the longitudes. We can subtract the longitude of vertex by 5 degrees or 10 degrees. In this problem, I decided to subtract the longitude of vertex by 10 degrees. Now, the first longitude can be obtained by subtracting 158 degrees 41.24 minutes east from 168 degrees 41.24 minutes east, which is equal to 10 degrees west. The next DLO can be obtained. The next DLO was obtained by subtracting 158 degrees 41.24 minutes east from 178 degrees 41.24 minutes east. The answer was 20 degrees west. And the last DLO was obtained by adding 158 degrees 41.24 minutes east to 171 degrees 18.76 minutes west. This will be equal to 330 degrees. Since it is past 180 degrees, we must subtract it from 360. The final answer is 30. The final answer is 30 degrees east. The first latitude can be obtained by cosine 10, which is from the first DLO, times tangent 45.09.5 minutes, which is equal to 0.9902657.6. And using the shift tan function, we can equal to 44.72 or 44 degrees 43.19 minutes north. The next altitude is also obtained similarly, substituting the cosine 20 from the second DLO from earlier. The answer will be 0.9449059, which is equal to 43.38 or 43 degrees 22.63 minutes north. And the last altitude, which is obtained by substituting 30 from the last DLO from earlier. Now we have cosine 30 times tangent 45 degrees 09.5 minutes, which is equal to 0.870825094, or equal to 41.05 or 41 degrees 03 minutes north. The last step is to illustrate. In the illustration, we must plot the point of arrival and the point of departure, also the vertex, and also the successive points of latitudes. Now the point of arrival is 20 degrees 30 minutes north, 90 degrees east, and the point of departure is 40 degrees 40 minutes north, 170 degrees. The vertex is equal to 45 degrees 09.5 minutes north, 158 degrees 41. The vertex is equal to 45 degrees 09.5 minutes north, 158 degrees 41.24 minutes east. The third successive latitude is equal to 41 degrees 03 minutes north, 171 degrees 18.76 minutes west. The second is 43 degrees 22.63 minutes north, 178 degrees 20. The second is 43 degrees 22.63 minutes north, 178 degrees 41.24 minutes east. And the first one is 44 degrees 43.19 minutes north and 168 degrees 41.24 minutes east.